we're going to continue this 1988 AP Calc BC multiple choice test. We left off on problem 21, so let's dive right in. Okay, so we have average value of 1 over x on the closed interval 1 to 3 this is very simple. We just have to remember how to find the average value, the formula for that. That's simply 1 over the interval, the length of the interval, so that 1 over 3 minus 1, integral from 1 to 3, which is the interval, of 1 over x dx. It's as simple as that. So this would simplify to a half. Integral of 1 over x is log value from 1 to 3, so this is just half ln 3 minus ln 1. ln 1 is just 0, so it's ln 3 divided by 2. And 1 is d. Okay? F of x is x squared plus 1 to the x. Then f prime of x is, here we have to use logarithmic differentiation. Okay, so if we let this equal to y, we say ln y, we log both sides, it'll be log of x squared plus 1 to the x power, which we can bring this power out in front of the log by properties of logs. Okay, so we can do it like this. Now we differentiate this side and this side, so it'll be 1 over y dy dx is equal to, here we would need product rule, so it would be first d second, we need to times 2x by the chain rule, plus second d first derivative of x just 1. Okay, so we get dy dx, we still have a 1 over y over here, would be, let's clean this up a little bit, it'll be 2x squared over x squared plus 1 plus log of x squared plus 1. Now we multiply by y on both sides, so dy dx is, y is equal to this, so we can write x squared plus 1 to the x power times whatever we have over here already. Okay, and that looks like E. Okay. Next, which of the following gives the area of the region enclosed by the loop of the graph? The polar curve R is 4 cosine 3 theta in the figure shown here. Okay, area of a polar curve is half integral r squared d theta. Okay, so it would be half integral of 4 cosine of 3 theta, all of that squared, d theta. What are limits of integration though? Well, when theta is 0, we'd be at the max over here. So if we traverse backwards, when is cosine of 3 theta 0? Cosine is 0 when it's like negative pi over 2 and pi over 2. Okay, so we can traverse back to, so 3 theta we want equal to, let me just write it like this. We want it equal to negative pi over 2 and pi over 2, right? So our theta would be negative pi over 6 and pi over 6, okay? So that would be our limits of integration, okay? And we can simplify. 4 squared is 16, divided by 2, that's 8. Then this is cosine squared, 3 theta, d theta, okay? So which one is that? 23 looks like it is E. Okay? That's how we do that. The important part was limits of integration. If C is a number that satisfies the conclusion of the mean value theorem for f of x is x cubed minus 2x squared on the interval x is between 0 and 2, then C is equal to what? Mean value theorem, remember what that says? It says, well, we know that this is differentiable. That's one of the conditions for mean value theorem. F has to be differentiable. There exists some value C in within the interval such that f prime of c is the average rate of change. Okay, so the average rate of change is here, f of 2 minus f of 0 over 2 minus 0. There's some value c where f prime of c is equal to this. Okay, so ignore that equal to 0 first. Okay, so what's f of 2 and what's f of 0? F of 2, we just plug in 2, so it'll be 8 minus 8, which is 0. F of 0 is just 0, so it'll be 0 over 2, which is 0. So f prime of c has to equal to 0. What is f prime? We just differentiate this, 3x squared minus 4x by the power rule. So we set it equal to 0. So that's what we want. We can factor out x from both terms, and our solution would be x is 4/3. Okay. Base of a solid is the region in the first quadrant enclosed by the parabola y is 4x squared, the line x is 1, and the x-axis. Each plane section of the solid perpendicular to the x-axis is a square. Volume of the solid is, this is a typical volume problem. Okay, so this is our region. Here's the parabola 4x squared. The line x is 1, that's this vertical line, x-axis here. Okay, cross-section perpendicular to the x-axis is a square, so I just drew a representative square. Okay, we want the area of the square, which is the length of the side, squared, and we multiply by infinitesimal with dx, and we integrate it out. Okay, so the limits of integration are from 0 to 1, that's where the region is. What's the length of the side? That's just the parabola, 4x squared. So 4x squared, quantity squared, dx. Okay, so this becomes 16x to the 4th, and then we just use power rule, 16 times x to the 5th over 5, we got it from 0 to 1, that is just 16 over 5. Okay, if f is a function such that f prime exists for all x, and f of x is greater than 0 for all x, which the following is not necessarily true. Okay, well, we know that f is always bigger than 0, so it's always above the x-axis. Okay, so the area from the integral from -1 to 1 is a positive area, so this is true. Okay, this one, this is just pulling out this constant, so this is true. This one is trying to use the property that f needs to be even. Okay, if it's even, then we can take half the interval and multiply it by 2 because of symmetry. We don't know if f is even, so this is probably the answer. This one, this is just flipping the limits of integration and adding a negative sign. That's valid. This one, this is just breaking up the interval. From -1 to 1, you can break up from -1 to 0, and then continue on from 0 to 1. So this is fine also. So answer is C. We don't know if f is even. If the graph y is x cubed plus ax squared plus bx minus 4 has a point of inflection at 1, -6, what's the value of b? Point of inflection, that should signal second derivative. Okay, so let's first find the first derivative. So if this is y, first derivative, we just use power 3x squared plus 2ax plus b. Second derivative, power rule again, 6x plus 2a. Okay, it has a point of inflection at 1, -6. So there's a critical point at x is 1. Okay, so again, I just said it's a critical point. So the second derivative is 0 at x is 1. So we plug in x as 1, so it'll be 6 plus 2a is 0. We solve for a. 2a is equal to -6. I just moved the 6 to this side, and I flipped the 2. So a is -3. Okay, now we found a, we need to find b. How can we do that? Well, we have this point. We can just use this equation up here. So -6 is 1, because x is 1, plus we found a to be -3, so -3 times 1 plus b times 1, which is b, minus 4. So we have a -3 and a -4, so that's -7 plus 1, that's -6. So b is equal to 0. Okay, so 27 is b. Okay. how to differentiate this guy? We just need the chain rule. Okay, so we first differentiate the outside and we go inward. So it'll be 1, so the derivative of ln is 1 over the argument, so 1 over cosine pi over x times derivative of cosine, which is negative sine of pi over x, times derivative of pi over x, which is minus pi over x squared. Okay, so we can rewrite this as what? We have sine pi x over cosine pi x, so that's a tangent pi over x. Okay, this negative and this negative make a positive. We still have a pi on top, and then we have the x squared on the bottom. Okay, so looks like 28 is E. Region R is in the first quadrant and is enclosed by the lines x is 0 and y is 5, and the graph of x squared plus 1, this parabola. The volume of the solid generated when R is revolved about the y-axis is, okay, so we know that this is a parabola. Actually, this is not the right problem. Where is my number 29? Did I not do it beforehand? Let me do it then. Okay, so let me get a piece of scratch paper. Sorry for the delay. I just said this is a parabola. We know how that looks. It opens upward like this, okay? And it's enclosed by the lines x is 0 and y is 5. X is 0 is here, y is 5 is up here, okay? This in the first quadrant, so it's only this side over here, okay? Okay, let's check one more time. Parabola, x is 0, that is this vertical line, y-axis line, y is 5 is up here, okay? Okay, so we should get there. The volume of the solid generated when R is revolved about the y-axis is, when we revolve around here, okay? We could use either the shell method or the washing method, doesn't matter. Let's just use the washing method, okay? So we can draw a representative R, okay? A radius, the representative radius, okay? We know that it's pi integral r squared dy, okay? Now, what are our limits of integration? This is in terms of y, so we limits in terms of what? We know that this parabola, this lowest point is at 1, okay? Because this is parabola shifted up by 1, okay? So it should be 1, and the highest point is bounded by the line y is equal to 5. What's r? Well, we need this guy in terms of y, x in terms of y. So y is x squared plus 1, or y minus 1 is x squared, or y minus 1 square root, but plus and minus is equal to x, okay? When we square it, the sign doesn't matter, so it becomes y minus 1 dy, okay? Now this is simple, that's just pi times y squared over 2 minus y, evaluate from 1 to 5. This is pi times 25 over 2 minus 5 minus parentheses 1 over 2 minus 1. Like this. I believe I did this in the AB exam, but that's okay. Let me just finish it. 25 over 2 minus 1 over 2, that's 24 over 2, which is 12. And then we have a minus 5, and then a plus 1. So this is equal to, that is 8 pi. Okay. We have this guy. I goes from n to infinity, some number n to infinity, 1 over 3 to the I power. This you should recognize as a geometric series. So that's the sum is the first term over 1 minus the common ratio. Okay, so this is, what's the first term? It's just 1 over 3 to the n power over 1 minus, what's the common ratio? That's just a third. okay, which is equal to 1 over 3 to the n power over the bottom is 2/3, so it should be, looks like it's C. Okay. This one, okay, this one is interesting. You could solve it by method of trig sub, and that's totally fine. Or you could be a little smarter about it. You recognize that, well, we know the equation of a circle is x squared plus y squared is some radius squared. So for example, 4, okay? So y would be plus or minus square root 4 minus x squared. So we have the positive, so we're actually finding the area of part of this semicircle, actually a quarter of this semicircle. Okay, so we know the formula for the area of a circle. That's pi r squared. R is 2, and we divide by 4 because it's a quarter of a circle. So this is just what? Pi 31c. So this is the quick way. You could do trig sub, where I think you would sub as x is 2 sine theta, something like that. I always show triangles. So I believe that would be the correct substitution to make. All right, here I'm not going to solve this one. This is a differential equation problem. Length of the curve, y is x cubed from x is 0 to x is 2 is, here we just have to remember the arc length formula. So I did that over here. This is the arc length formula. So we need 1 plus dy dx squared. So if y is x cubed, dy dx is 3x squared by the power rule. So we square that, that would be 9x to the 4th. We add 1 to it. Okay, so it'll be integral from 0 to 2. That's where we want the arc length, right? From x is 0 to x is 2 of square root 1 plus 9x to the 4th. Okay, and that is 33 is E. Curve in the plane is defined by the parametric equation x is t cubed plus t, y is t to the 4th plus 2t squared. Equation of the line tangent to the curve at t is 1 is, well, remember, defined, okay, well, first of all, to find equation of tangent line, you need a slope, you need a point. How do we get the slope of the tangent line? Derivative. How do we find the derivative of parametrically defined equations? For parametric, it's easy to remember dy dx is dy dt over dx dt. Again, you can think of it as these dt's cancel out, so you get dy dx, okay? So dy dt, just the power rule, it'll be 4t cubed plus 4t. Okay, that's what I got there. Power rule for dx dt, 3t squared plus 1. Okay, we evaluate at t equals to 1. That's where we want the slope of the tangent line. So that's 4 plus 4 over 3 plus 1, okay, which is equal to 2. So when t is 1, we need a point now. So when t is 1, what's the x coordinate and what's the y coordinate? You just plug in t is 1 into here, so it'll be 2. T is 1 into here, it'll be 3. Okay, so we have a slope, we have a point, begins point slope form. Y minus 3 is 2 times x minus 2. We get in slope intercept form, it would be 2x minus 1. Okay, so y is 2x minus 1 is the solution. If k is a positive integer, then limit as x goes to infinity of x to the k over e to x is what? Okay, so we know that k is some positive integer that's finite. It doesn't say that, but it doesn't say it's infinite. If it's infinity, then it's not integer, right? So eventually, by L'Hopital's rule, this would eventually go to some constant. So it'll be some constant over e to the x. Okay, so the limit of some constant over e to x as x goes to infinity, that is 0. Okay, and why could we use L'Hopital's rule? Well, it's infinity over infinity. Okay, let R be the region between the graphs y is 1 and y sine x from x is 0 to x is pi over 2. Volume of the solid obtained by revolving R about the x-axis is given by what? Okay, so this is the one I showed a little earlier on accident. Okay, so I just graphed a little bit of y sine x, that's this curve here, and we're only interested in from 0 to pi over 2. So we actually cut it at the peak of the sine wave, okay? And we're bounded by y is 1, so that's this line here, and x is 0 to x pi over 2, so this is our region over here that's shaded, okay? Because it's between y is 1 and y is sine x. So it's the shaded region. All right? So we revolve it about the x-axis. We revolve it here. So I drew a representative r out and r in. R out, sorry, is the long one. R in is the short one, okay? So volume is pi integral of r out squared minus r in squared dx. Okay, so limits of integration are from 0 to pi over 2. That's where our region lies in terms of x. So 0 to pi over 2. R out, what's the length of r out? That's always just 1. 1 squared minus what's the length of r in? That's sine x, quantity squared, so sine squared dx, okay? So that is C. Sorry, that's not correct. I scored the wrong one. It is this one. Okay, so let me erase. It's not that one. Okay, it is E. I got the right answer. I just circled the wrong one, my bad. E. Okay. And actually the answer key says E or D. I don't see why that would be the case right now. Well, actually, since this is a cosine squared, maybe the integral of sine squared in this and cosine squared is the same thing. So maybe D could work. Maybe that's why. Okay, but just by me showing you how I set it up, E. Okay, once again, this definite integral might end up being the same value. So maybe that's why they said D or E. Okay, a person 2 meters tall. Okay, this is a harder problem. A person 2 meters tall walks directly away from a street light that is 8 meters above the ground. If the person is walking at a constant rate and the person's shadow is lengthening at a rate of 4/9 meters per second, at what rate in meters per second is the person walking? Okay, here it's one of the more difficult types of related rates problem where you have to use similar triangles. So let's sketch out what's happening. This is the lamppost, 8 meters tall. This is the person, 2 meters tall. Okay, and this person is walking away from it at a constant rate. Okay, and the shadow is lengthening at the rate of 4/9. So I wrote ds dt is 4/9. I drew this guy as a shadow. Okay. They're asking about what rate is the person walking. So this is some distance x between the light and the person. So the change in that distance with respect to time would be the speed of the person. So where did I do that? We would want dx dt basically. That's what I'm trying to say. Okay, once again, this is the light post, street light. This is the person. This is the shadow that it casts. And the person is walking away from it. So the change in the distance between the light and the person with respect to time, that's the speed. So we're interested in dx dt. Okay, so we have to use similar triangles as I hinted earlier. We know that since they share the same angles, it's a similar triangle. Okay, by similar triangles, the ratio of the sides are the same, if you remember back in geometry. So if this ratio of the two sides here, so this base and the height, so I wrote s/2 of the small triangle, is equal to the ratio of the base of the big triangle, which is x plus s. So that's what I wrote here, divided by the height, which is 8. Okay, we cross multiply, so it's 2x plus s is equal to 8s. We distribute, 2x plus 2s is 8s. 2x is equal to 6s. Okay, so I combine these two to 6s. We solve for x. X is equal to 3s. Okay, Why do we want to do that? Because now that we have this formula, we can differentiate with respect to time. So dx dt is 3 ds dt. Okay, so we know what ds dt is. We want dx dt, so that's how we solve for it. 3 times 4/9, we're given that, which is 4/3. Okay, that's how we solve that one. So this is one of the more difficult types of related rates problems with similar triangles. Okay, and we're 25 minutes in. Yeah, let me just call it a part here, and we'll finish up the remaining problems in part 3. So please give this video a like if you found it helpful, and please subscribe to the channel to look out for part 3.